Welcome to a new video which is about limits in composite functions. In the video I will explain the rule and continuity of composite functions first and then solve 3 instructive examples regarding the subject. If this is your first time here and if you want to support this channel, don't forget to subscribe, click on the bell to turn on the notifications to be aware of the upcoming videos. We have a lot to cover, so let's get started. In this video, guys, we have a theorem about continuity, and as we see here, we have C point, we have f of C point, and then we have g of f of C point. What this theorem tells us is if f function is continuous at the point C, and if g function is continuous at the point f of C, and then g of f function is also continuous at the point C, guys. If we have something like g of f of x, that operation means actually a composite operation. We can think this whole term as g of f of x. When we say g of f of x, so we go in this way. But once we investigate the function, composite function, then we start from very inside. So we just put x in the function f, and then after we evaluating f of x, then we just put this f of x also instead of variable in g of x. That's what we do here. And we have also a rule here. Suppose that limit of g of x when x goes to a is c, and then limit of f of x when x goes to c. If you realize this is the same c, guys, okay, that is important. And then this is also equal to n. If f is continuous at the point x is equal to c, then we can write this expression in this form. As you can see, we have f of g of x here, and then what we do is we just bring this limit inside. So just leave that f out and then just bring limit inside. That's what we can do here. I believe that we're going to understand this topic easier once we look at the examples. And let's take a look at our first example. And this is our first example. We have g of x and f of x. We're asked to find the value of limit when x goes to 2, f of g of x, guys. We can interpret this as limit when x goes to 2, guys, f of g of x. We will find g of x, the limit of g of x, first when x goes to 2, and then we will evaluate the limit of f of x. So let's find limit when x goes to 2 of g of x, which means x squared plus x minus 1, guys. And that is equal to what? Well, we can just easily evaluate this limit by just putting 2 instead of x. That's all what we're going to do here. And once we do it, we're going to have 2 squared plus 2 minus 1. And that is going to be 4 plus 2 is 6, and minus 1 is going to be 5. For the rest, what we're going to do is limit when x goes to 5, what is the limit of f of x. So this is what we're going to do. And then this is equal to, guys, f of x is already x plus 2. So we're going to have a limit when x goes to 5, x plus 2 is going to be basically just 7, guys. This is the common way that we solve limit questions in composite functions. But there is also another way by using the rule that we just learned in this video. And as you can see here, our functions f of x and g of x, they are both continuous functions. Why? Because if you put any x, then you obtain a y as a result of this function. And this is true also for g of x. So both f of x and g of x, they are continuous functions. That means, guys, we can just interpret this as f of limit when x goes to 2, g of x. We can find out the solution by using this rule as well. And once we do it, let's find limit of g of x first. Actually, this is what we found here, and that is 5. Right? So we're going to have f of 5. F of 5 is going to be what? Just put 5 instead of x, and this is going to give us also 5 plus 2, which is 7, guys. So you can also use the rule that we just learned in the previous scene. And let's continue with the next question. In this question, guys, we are given g of x as 3 to the power of x plus 1, and f of x as in the square root 3 times x. And in this case, what is the value of limit when x goes to 1 of f of g of x? This is equal to limit when x goes to 1, what is f of g of x? So we will start from the g of x first. So I will find out what is limit when x goes to 1 of 3 to the power of x plus 2, guys. And what I'm going to do, guys, just basically put 1 instead of x. So once we do it, we're going to have 3 to the power of 1 plus 2, which is 3. So this is going to be equal to 27, guys. So that means I will just evaluate f of 27, guys. And once we do it, of course, f of 27 is going to be in the square root 3 times 27. And this is going to give us in the square root 81. And that is 9, guys. And let's take a look at our last question. Okay, guys, this is our last question. And in this question, we are asked to find the limit when x goes to 3 from the right side, f of 2x minus 4 divided by f of 5 minus x. Here what we're going to do is, if you put 3, okay, we're going to put something a little bit bigger than 3 because x is approaching 3 from the right side. Suppose that we are just putting 3.01 instead of x. So once you put this value inside the f function here, then we're going to have, the inside is going to be 2.02. So this is what we're going to have from here. We're going to have from here 2.02. And in the denominator part, if you do the same thing, we're going to have something 1.99. So we're going to have something like this. For f of 2.02, we can think it as limit when x goes to 2 from the right of f of x, guys. So we can think of this situation as limit of f of x when x goes to 2 from the right side. And for the denominator, for f of 1.99, we can think this situation as limit when x goes to 2 from the left of f of x. So as you can see, when x goes to 2 from the right, the limit is 8. Okay, so it's going to be 8 divided by when x goes to 2 from the left, and then the limit is going to be 4. So we're going to have 8 divided by 4, which is going to give us the result as 2, guys. And sometimes you might have one-sided limits as we see in this question, and you can treat these questions in this way. And this question was our last question, guys, in this video. If you have any question, you can put them in the comment section below. Thank you for watching, and hopefully see you in the next video.